Hi, good afternoon. I'm Sunny Song, technical engineer in charge of ASEAN region. Let me talk a little bit about the total cost of ownership. Yeah. Now, assuming you have all the racks, the 8 racks here, and you require to deploy these 8 racks, assuming if you use a 6 terabyte air drive and an 8 terabyte air drive versus a 10 terabyte helium drive, okay? The capacity actually, with the same amount of racks and the amount of power, you can actually gain 25% in capacity, right? And in terms of power, okay, in terms of watt per terabyte, it's actually 0.5 watt. So the amount of saving that you actually save is huge in terms of dollar per terabyte. Okay. Now what it means is, with the same amount, the same rack, you actually uses a lot of same hard drive, but with the same amount of power. But in terms of dollar per terabyte, okay, your wattage actually reduced. Okay. Now, this is our 3rd generation of helium drive. Okay. Now, what is so special about helium drive? In the helium drive itself, we actually uses helium gas to replace air. Okay. As you know, helium is lighter than air. So when the drive starts spinning, okay, the friction created by the air on the head, okay, actually create a lot of heat. Okay. So a drive will be heated up. Once the drive is heated up, okay, it will use up more power. Okay. On top of that, most of the time the drive fails due to over temperature. But with this helium inside, it actually reduces the friction. And on top of that, we can actually put 2 more extra disks inside the same hard drive. That's why we managed to be able to gain more capacity with the same hard drive. Okay. This is a proprietary feature that we have. We actually call it Helio Seal and this tag. Okay. Why is so special? Because in order to keep the gas inside from escaping, is actually a very delicate way to do it. You need to actually seal it completely. Right? Yeah. So that's the main thing. Now, last time, the 1st generation, the amount of difference between air and helium drive is a little bit higher. But as we go along, the price actually reduces, coming to very close. Okay? Now, for our 3rd generation of helium drive, okay, which is a 10 terabyte drive, okay, it's actually very suitable for a lot of cloud and data center customers. Like currently Google and Facebook, among other companies, Dropbox. Many are using this drive. And as you know, we also do have the air drive. This is our air drive, a 7K6000, a 6 terabyte drive. Okay. What happened is, this will be the last generation of our air drive. So moving forward, all capacity enterprise drive that we have will be only helium. Okay. So that means helium is something which we actually look forward to. Okay. Maybe in future we will be having a 12 terabyte drive. Okay. And of course, the 6 terabyte air is also 2.5 million hour MTBF. Now, we also have the 2.5 inch 10,000 RPM drive, okay, which is a SAS interface only. Okay. This is the fastest 10,000 RPM drive in the market. And of course, we also have a 15,000 RPM drive, 2.5 inch, maximum capacity 600 gig. This is the fastest 2.5 inch 15,000 RPM drive in the market. We also have a SSD line up here. Okay, SSDs also contribute a lot to the green IT. Okay, on top of our helium drive. Okay. What actually happened is the power consumed for SSD is so much lower than the hard drive itself. And of course, in terms of performance-wise, SSD is so much faster. Okay. We do have two types of SSDs. We have a SAS SSDs and a PCIe SSD, which consists of NVMe. Okay. Look at this. In terms of performance, okay. For SAS, it can go up to 130K IOPS per second for read and 110K IOPS per second for write. Okay. Of course, endurance level. I'm not sure you all know about endurance level. Because the NAND cell itself actually have an endurance level. That means how many times you can write to the cell before the cell unable to hold any more charges or store any more data. Okay. Now we do have three types, okay, which is 25 dry writes per day, okay, for 5 years. This is high endurance. For medium endurance is 10 dry write per day, okay, for 5 years. And of course the read intensive. Read intensive is actually 2 dry write per day for 5 years. Basically, in terms of tiering, okay, maybe you would like to have a drive for write catching or read catching. So that's how you actually select certain type of drive for your tiering purposes. Now for NVMe, this is PCIe based. Okay. In terms of performance, this is the fastest available in the market right now, compared with SAS SSDs. Okay, if you do take a look, okay, for random read-write IOPS, 70%, okay, you can actually go up to 700 over K IOPS per second. Okay. So, let's say you got a customer that requires very fast performance requirement, but you need it to be have a lower power consumption. These are the ways to go. Okay. Rather than to put a lot of drive and stripe it together, the performance, no matter how, would not be able to attain such a speed. Now, why our NVMe is very, very fast? Because for NVMe to be super fast, you need to reduce the latency. Okay, latency is the key. Okay. Now, here we are. This is our NVMe as to compare with our competition. Okay. So the faster it is in terms of dollar performance per wattage, okay, it actually reduces the power as well. We also have just announced 4U60J board. Okay. And of course, J-board traditional market is actually using RAID. So we actually try to engage in this market as well. Right. So our 4U60 enclosure, all this will be using chip fully populated with helium drive. Okay. And helium drive, 480 terabyte, 60 drive is 480 terabyte. This will be fully helium. For the rest of the other capacity, 360 and 240 terabyte. Okay, these are all air drives. Okay. Now, just now that one you can actually create RAID or JBOD with it, just pure JBOD. For this, we actually have an active archive system. This is a RAIDless technology. We are using erasure coding. Okay, what it means is when you send a block of data to this system, okay, you actually split it out into 18 chunks. And all these 18 chunks of data will be stored across all the hard drive over here. Okay. In case there's a hard drive failure, it can take up to 5 drive failure without any issue. And these are rateless. It's actually what we use, the technology here used is actually erasure coding. Okay. Now the capacity for this is actually 4.7 petabyte raw. Okay. So this is something that we have. Okay. And in terms of lowest power per terabyte, okay, this is one of the highest capacity that we can offer. Okay, thank you.